Welcome to part 2 of Seminar 1. We go on with what is addiction, and in this section we will start by looking at brain biology, dopamine, and how dopamine is involved in learning. So this is a photo of nerve cells growing in a petri dish or a glass dish. They naturally branch and connect with each other, and in the brain we have roughly 100 billion nerve cells, each nerve cell with 10,000 connections to other nerve cells, producing a total of 1,000,000 billion or a quadrillion connections in our brain. And these connections form the basis of our behavior and learning. We will also look at dopamine and its role in pleasure, learning, learned associations, and addiction. This is a short video just showing how nerves communicate
Neurons
with each other.
talk to each other using both electrical and chemical signals. Messages start as electrical signals traveling rapidly down a neuron. These signals are called action potentials. When they reach the gap between two neurons, the messages need some help to get across. The information is transformed from an action potential into a chemical message, which crosses the gap called a synapse. The release of those chemical messengers can trigger an action potential in the neuron on the other side of the synapse, conveying the message onward. Or it can quiet the message. This happens over and over and over. And with repeated activity, the synapse gets stronger, so the next message is more likely to get through. That way, neurons learn to pass on important messages and ignore the rest. This is how our brains learn and adapt to an ever-changing world.
Let's look at this short video on the limbic system, which is the brain's center for perceiving pleasure, automatic learning, and the ability to give
The limbic
attentional
system
focus.
contains the brain's reward circuit or pathway. The reward circuit links together a number of brain structures that control and regulate our ability to feel pleasure. Feeling pleasure motivates us to repeat behaviors, such as eating, and other actions that are critical to our existence. A reward, or something linked with a reward, activates cells in the ventral tegmental area, or VTA, in the midbrain. This sets off a chain reaction of activation in the reward circuit. The activation of cells quickly reaches a key part of the VS called the nucleus accumbens. The nucleus accumbens is often called the brain's pleasure center. When activated, each cell generates an electrical signal. That electrical signal causes the cell to release molecules of neurotransmitter, which act as chemical messengers. Those chemical messages are received by another cell. This is how cells communicate with each other in an activated neural circuit. In the reward pathway, dopamine neurons release the neurotransmitter dopamine. The released dopamine molecules drift across the synapse. They link up with proteins called dopamine receptors on the surface of the receiving cell. These receptors span the receiving cell's membrane, with part on the outside and part on the inside of the cell. In a healthy brain, there is always a moderate level of dopamine in the synaptic space, even in the absence of rewarding stimuli. When a reward is encountered, such as food, the presynaptic cell releases a larger amount of dopamine in a sudden burst. Dopamine transporters will then quickly remove the excess, returning the amount of dopamine to the original level. Dopamine surges in response to natural rewards help the brain learn, adapt, and navigate a complex world. Activation of the reward pathway has a far-reaching impact throughout the brain. From the VS, the reward pathway extends to the prefrontal cortex, or PFC. The PFC powers our ability to think, plan, solve problems, and make decisions. The reward system influences the limbic system and the areas of the cortex that process sensory and motor information. Reward system activation also influences the cerebellum in the back of the brain, which affects coordination of movement as well as attention. Normal activation of the reward system creates a physical imprint on the brain that links certain stimuli with rewards that satisfy biological needs, such as food, and make us want to fulfill those needs by seeking out those rewards. Once the brain associates a stimulus with a reward, just seeing the stimulus can trigger a surge of dopamine in the reward system.
We've seen how associated things that occur at the time of, say, eating, when there's a pleasurable response, become connected and integrated, and it's a biological phenomenon that we don't have any control over. This sort of thing happens, is exploited by companies to sell their products. For example, fast food chains, the food is quite extra tasty with extra salt and sugar, which heightens the reward, increases the amount of dopamine. And then there's a certain associated symbols and decor, which when just driving past will trigger that association. And even if you're not particularly hungry, it will start making you start thinking about food, the pleasure that you had last time. So this associative learning is widespread and can be exploited. So we've seen that that learned association is mediated through the release of dopamine, the heightening of those circuits, which then through strength of the signal and the repetition leads to stronger associations and learning. Chemicals can produce higher levels of dopamine than naturally occurring stimuli. So we have here food in the red, and sex is hidden under that green line there. The blue line is cocaine, but this lavender line is methamphetamine or ice. So we can see the amount of dopamine that's released is vastly higher than naturally occurring rewards. And this produces a very deep imprint in the brain of not only the reward of that chemical, but also the whole associated scenario around that. So instead of a craving that most of us could resist, if not without a little difficulty, such as the urge to eat food, the urge to seek a drug is extremely powerful. And without a well-functioning and strong frontal lobe, it becomes quite unlikely that the person will resist that impulse. And certain associations make it all that much harder. So seeing pictures or actual paraphernalia of drug use, the sight of money that was involved in transactions, certain locations, say for example where people have scored drugs, messages, contact from other people. The actual feeling of withdrawal was also a trigger. It triggers a memory of the relief of that withdrawal through substance use, associations with other people, and even the time of the week. For example, payday or a Friday night can trigger that craving for the substance, which has been laid down through an association. So we've just seen how dopamine is involved in that basic learning, learning through association, that is sights and sounds and smells and people that we're with are kind of snapshotted at the time when we have that pleasant experience. But there's two aspects to dopamine in addiction, and one is that involved
This
in
is your
pleasure.
brain.
The second aspect is that
Here are
that
the neurons that
release
produce dopamine.
is what powers our
When
frontal
these neurons
lobe.
are activated,
It
they
actually
release
stimulates our
dopamine
ability
here
to think.
in the frontal lobes.
And with substance use,
Dopamine is motivation.
dopamine function can
When dopamine is
decrease over
released, you
time,
feel motivated to
and
keep
this
on
can
doing
affect our
whatever it is
ability
you're doing.
to reason
Dopamine
and
is what
make good
makes things
judgments.
seem important and
Let's watch
meaningful.
this short video.
Your frontal lobes are where thoughts are formed. If your frontal lobes are low on dopamine, you get bored and start looking for something that can stimulate your dopamine neurons to release more dopamine into your frontal lobes. Food, drink, sex, social pleasure, and addictive drugs activate dopamine neurons directly. That's why they can be so addictive. Interesting sights and sounds can also activate dopamine neurons. That's why you're still watching this video. The frontal lobes themselves can form a positive feedback loop with the dopamine neurons. This is called thinking. Very few people can form feedback loops like that without thinking. That's called meditation, and it's really difficult. Most people need to think about something interesting, something they're doing or looking at, or something that's happened to them in their lives, and plans and hopes they have for the future. That's why we never stop thinking. Our frontal lobes are drawn to whatever thought releases most dopamine. That's also how long-term thinking and self-discipline works. We use our frontal lobes to activate our dopamine neurons even when what we're doing is boring or difficult. People vary in how well their frontal lobes can activate their dopamine neurons. People with attention deficit disorder or addiction have great problems with it, and most of us find it difficult to go for a salad and supply our own dopamine rather than having a burger or a cake, which activate dopamine neurons directly. Personally, I think we all struggle with how to activate our dopamine neurons. What we do doesn't seem very meaningful, and the few things that really motivate us are short-sighted things that don't involve our frontal lobes much and that get us into trouble in the long run. If only there was a different way.
So after that slightly philosophical and humorous end of the video, let's look at the effect of drugs on dopamine function of the limbic system. This is a slide showing scans, special scans where chemicals that attach to the dopamine cells of the brain show up on scans. The top shows a normal person that's never used substances, and the bottom slide shows someone who's used ice or methamphetamine chronically, showing a reduction in dopamine function. In this group of people who've had the scans, they've also performed tests of their motor function, that is the ability to do physical actions involving some degree of executive or higher function, and also memory tasks. And it shows that the lower the dopamine function, the longer it takes to do memory tasks and motor tasks. So therefore, there is this hidden deficit that occurs in people who have used substances chronically and cause damage to their dopamine pathways, where there's just not enough frontal lobe stimulation with dopamine to allow them to function optimally. Besides the damage that substances can cause through the dopamine pathways, substance use can be associated with frontal lobe damage or impairment through pre-existing conditions such as ADHD or mental health issues, impaired development, say teenage substance use or psychosocial poverty, which can affect the overall development of the brain. Direct toxicity from the drug itself on nerve cells in general, such as through alcohol or solvent use, and damage secondary to drug use, such as through head injuries, fights, strokes, for example, in amphetamine use, infections in the brain as caused by bacterial abscesses and infections. Psychosis itself can cause cognitive impairment after severe or repeated psychosis, and oxygen deprivation through overdoses, near misses, and suicide attempts. All these things can affect the frontal lobe and therefore the ability to maintain a balance with regard to animal brain impulses. So let's look at brain recovery from addiction. And there's two aspects to it. One is to do with the limbic system or the animal brain. The other is the frontal lobe or the smart brain. Time away from the drug, there's no substitute for that. We can see in this slide that the dopamine function recurs with abstinence over a 6 to 12 month period. And during this period, there will be a lot of craving for the drug because the person will just feel a lack of interest and motivation in general. So it's important that they get a lot of support and understanding during this time. And during this time, the reprogramming of the frontal lobe, which is the other aspect, needs to occur. And this happens in counselling and groups. And the aim of this reprogramming is to strengthen the motivation, that is resolving the ambivalent thoughts about drug use, good healthy social connection, that is not just in recovery groups of people who are focused in the same direction, but also family. Unconditional positive regard for the sufferer is very important, not without boundaries in place, yes, but that positivity and encouragement is important. Skills acquisition, specifically around drug refusal, craving, analysing behaviours and beliefs that are unhelpful, and learning to substitute new behaviours and beliefs is important skills to acquire. Managing triggers, that is for the same trigger, learning new behaviours and beliefs, but also learning to avoid triggers that, if possible, learning to manage the triggers. So, for example, payday is a regular trigger that is unavoidable, and how to cope with that trigger. For example, getting someone to manage to hold their key card and to go shopping with them the following day to get their bills paid and groceries purchased. Planning for the future is another key issue. People need to start looking forwards and doing things that are healthy and leading towards a drug-free lifestyle. So by focusing on reprogramming and also abstinence from drugs, this gives us the greatest chance of improving and recovering from the effects of drugs on the brain. Up to now, we have approached addiction as a complex biological, psychological, and social phenomenon. But what about choice? Whilst animal models demonstrate that humans can be carried along by the same sort of biological and psychological processes, the frontal lobe, with its unique capacity, allows man to have human choice. What that means is contentious. One only has to look up the subject of free will in Wikipedia to see a very long essay and varying conflicting philosophies on the same subject. Yet society's attitude towards addiction demonstrates that there is a common belief in moral responsibility for choices that result in addiction and its consequences. But is this fair? The frontal lobe may be in such bad shape due to heredity, development, and past or present circumstances that decision-making ability is poor and options limited. Guiding principles may be obscured, and those that are present may have been born from poor role models or shredded by trauma. Yet, whilst it is difficult, choices do exist. For example, to try a less damaging way of using, to note down an emergency phone number, to block a dealer's phone number, to attend a meeting, or even just to pause and think for a moment before acting. As a society, it's tempting to look at the terrible final results of a series of incremental bad choices rather than considering the whole context and the relative psychopathy, that's a scientific term for badness, involved in day-to-day choices. Most people who use drugs do have a conscience about their bad choices. It is often only in a state of drug-induced intoxication or during the severe duress of withdrawal that sometimes heinous acts are perpetrated. And this is often followed later by deep remorse. Human choices, whether our own or others, inevitably lead to issues of shame, a sense of injustice, deep bitterness, the big why questions, and these are not always resolved by a traditional psychological approach. In recent decades, new approaches have emerged which are informed by particular philosophical viewpoints, often called third-wave psychological treatments. These are underpinned by big picture ideas or beliefs which help people reframe or come to terms with their experiences, teach them new skills, form recovery groups, and even faith communities. ACT or ACT, DBT, 12-step programs are examples of these. They have in common a philosophical or belief-based underpinning, which is not scientifically verifiable, but which may work or not for a given person. In summary, choices obviously are important. However, given the many unseen factors in the life of any one person, a value judgment or blaming the addicted one does not stand up to honest reflection and have little positive effects on the addiction process. On the other hand, unconditional positive regard with boundaries is beneficial. In ordinary language, that means committed love, good self-care, and fair consequences. These have been shown to be very beneficial. This is the end of this first section, and we shall go on to look at what leads to addiction, who's likely to become addicted. I should have said that's the end of part 2 of Seminar 1, and part 3 is to follow.